Welcome to the first episode in a mini-series in which iCellate is going to tell you a bit more about the projects that we're working on. I'm joined here by Helena Silva Cascales. She's the leader of the Elevate project. iCellate is advancing cancer diagnostics through liquid biopsies, and Helena is going to tell us a little bit about the Elevate project. The project focuses on pancreatic cancer. Tell us why.
Well, pancreatic cancer is currently the 11th most common cancer worldwide, and while it affects a relatively low number of people, it has a disproportionately high number of cancer-related deaths.
Okay.
And this comes mostly from the fact that the diagnosis is happening at very late stages of the disease, and at this stage the treatments are relatively ineffective and actually there are not many available, and they tend to be rather invasive. So there is really a need for improved treatments and diagnostic methods.
Great. How are we going to achieve those things?
Well, with this in mind, a consortium of industry partners and academic partners has been put together to develop a EU-funded project to find a new immunotherapy that's combined with several different ways of diagnosing patients. And in this project, iCellate has the role of developing an assay to detect the patients that can benefit from this particular immunotherapy that I will go a bit into detail a bit later.
Perfect. And iCellate is focused on diagnostics through liquid biopsy. Mm-hmm. So tell us a little bit about what a liquid biopsy is and why we decide to pursue them.
So the main advantage of liquid biopsies is that they're relatively simple to perform because they're based on the exploration of different fluids in the body, like saliva and blood. And as such, they are easily accessible by a simple blood draw, and we can repeat the measurements and the analysis. On top of that, the fact that we can detect specific markers in the blood, we can identify very specific cells from very early stages of cancer progression. And that gives us the opportunity to to identify cancers when they are still at very early stages of their development.
So it sounds like they can both be used as an alternative to tissue biopsies, but also perform analyses that we're not able to perform on tissue biopsies today.
Exactly. And because we can draw blood from the patients at very different points, we can not only diagnose the patients, but once they are under treatment, we can take a new sample and find and see if we find any of these cancer cells that are potentially causing metastases and problems. So they really are a very powerful way to diagnose and monitor patients. Okay, let's take a look at the role of the immune system in cancer development. In the very early stages of tumor development, we have the cancer cells that start proliferating. And when they do that, there is an intrinsic heterogeneity in the tumor. That means not all cells are the same. And some cells can be recognized by the immune cells that are present in the tissue. And these are represented by gray cells here. Then immune cells can recognize these cancer cells and elicit their destruction. That, of course, is very nice, but that only gives the remaining cancer cells a proliferative advantage over the ones that are recognized by the immune system. So when we progress in the disease, we get that cells continue proliferating in the tissue, and that at this stage there is a carcinoma in situ. Now, when the disease continues to progress, the tumor continues to grow, but on top of that, we find some cells that can leave the tumor and create metastases in distant locations. And it is, of course, mostly due to the process of immune evasion that these cells can establish themselves at distant locations in the body and create these metastases. So, of course, it is very important to understand the role of the immune system in cancer development and how we can modulate the role of the immune system to our advantage. So in recent years, there has been a very strong interest in the development of immunotherapies for cancer treatment. Immunotherapies aim to treat diseases through the modulation of the immune system, either by promoting its action or by suppressing their activities. Elevate focuses on a second-generation active immunotherapy, and that means that it targets both cancer cells and immune cells to elicit a response that will, in the end, lead to the destruction of cancer cells. How this happens is by the development of a specific molecule that consists of a molecule that recognizes an immune cell and a part of another molecule that recognizes a circulating tumor cell. And these two are bound together into a so-called bispecific T-cell engager that is then administered as a drug to the patients. And this drug has been developed by Elthera, which is one of the partners in Elevate, and it goes by the name LMAP. The technology that we're currently developing is a liquid biopsy assay to identify patients that can benefit from the treatment with LMAP. As such, the first step is to identify that the patient has circulating tumor cells that express the specific marker that LMAP can recognize. This is done by drawing a blood sample from the patient and analyzing it for the presence of circulating tumor cells positive for the specific marker. If the tumor cells are positive for the specific marker, the patient can be selected for treatment with LMAP. And what LMAP will do is that it will recruit an immune cell and bring it to the proximity of the specific circulating tumor cells and elicit their elimination. Now, this technology can be used as a minimally invasive early detection tool for pancreatic cancer, as well as to select pancreatic cancer patients for treatment with LMAP. As well, because the biomarker that LMAP targets is not exclusive to pancreatic cancer, we believe that this technology has the potential to select patients for treatment with LMAP across cancer types.